So yeah, we're doing actually the third fruit fly experiment in the last 7, 8 months. We had one on SpaceX 3, one on 4, and now one on 5. And so let me start out by telling you a little bit what this experiment is about and what's unique about it. And then I will go on to giving you a little bit of a background of what the other ones were so that you get the big picture of why we're interested in using fruit flies in space. So one question that a lot of people come up with is like, fruit flies, really? You know, what's the excitement about fruit flies with doing science? Now, something that you would have heard from a lot of the speakers earlier is that the big picture is that we're interested in humans being in space for a period of time. But you'll know that there's a lot of experiments you can't do with humans. You can't do a lot of the genetic stuff. You can't do dissections. You can't extract, tissue samples and look at the molecular biology of what happened. You can extract some from humans, like blood samples and urine samples, but there's a lot that you can't do for the human, and yet you want this information for the human. So fruit flies serve and have actually been used for the last over 100 years in biology labs across the world to understand a lot of very fundamental things like, how does your heart function? How does your immune system function? How does aging happen? How can you reduce aging? All of these are questions that you can actually answer, and many more that you can answer with a fruit fly. So what we're doing on this mission on SpaceX 5 is we are flying, so I'm actually very excited because the last 15 years that I've been working at NASA, this is what I've been hoping to get to the public, which is a facility that scientists all over the world can use to do Drosophila experiments in space on the International Space Station. So what's unique about this particular hardware, this facility that we're putting up? It'll have the capability to, actually many things. So one, it's going to have the capability to have what is called a 1G control. So you have a centrifuge so that half your samples, actually a third of your samples are in the microgravity environment of space. A third of your samples are in a 1G control in space. And a third of the samples then are on the ground as your control. So the advantage of this is if you see a change in space flight, you can now start asking the question of, was it the micro-G environment that did it? Or was it radiation, vibration, something else from space flight? So having the two control groups is a really nice way to do the experiment. So that capability is available on this facility. There's a high-definition video camera, so you can look at the status of the flies, the health, how many are coming out, when are the children and the grandchildren being born, for the flies, and monitoring exactly how long development took. You can study how development is happening because the fruit fly actually serves as a very universally accepted model organism for studying development. And that same development, many of those same processes happen in human development as well. So there's the camera, there's lighting. So just like on Earth, we have 12 hours of day, 12 hours of night. We have the capability for circadian lighting in this hardware. We also are, for the first time, going to take samples and do fixation with them. So scientists who want to fix their samples will have the ability to do that. What else? Oh yes, of course, multi-generational capability. So we can now, as many of the cassettes that we send up, and I actually really wanted to bring a cassette for you, but you'll find pictures of it all over the web because we have a lot of outreach things that we've done before. So just search for my name, Sharmila Bhattacharya, NASA Ames, and you'll see pictures of our hardware. But we can actually separate generations through multiple generations and do studies that way. So that's the facility aspect of this experiment that's exciting because this is now a capability that anyone can use. You write grants, you use it through CASIS, you use it through NASA, you can do it through foreign entities applying through their space agencies as well. So there's that. And then the second part, that I'm a scientist, so the part that excites me also, is the fact that we're also going to do an experiment here where we're going to look at the immune changes. So we're going to look at how well is the fly able to fight an infection, just like you fight off your cold or a stomach bug or something. So we're giving the fruit fly an infection, something that's pathogenic to the fly, and we're going to watch how effectively it's able to counteract that infection in space. So that's the science aspect of it. And then we'll go to questions, but before that, I just wanted to wrap up with what were the two other experiments that I just talked about that many of you heard and were here and we discussed earlier for SpaceX 3 and 4. We've started getting some very exciting results on some of those, and just to give you a little idea of what else you can do with these small critters that you most likely want to swat in your kitchen or in your bathroom, but that serve as a very useful tool to scientists. We've been using, for SpaceX 3, we use it for a cardiovascular experiment, and we're getting some very neat data on flies that developed completely in space, and how the spaceflight environment altered cardiovascular function. And many of those functions actually mirror some of the changes that you see in astronauts. Same with the earlier experiment we done before that on the immune system. Many of the changes that we saw in the immune system also mirror what you see in humans. So in other words, they are very useful tools to then understand the molecular biology of what's happening in the body, because instead of now having 6 astronauts in space, all of whom are of different ages, different sex, they are from different ethnic groups, they're from different genetic backgrounds, they eat different food, they have different predispositions to anything that you can think of. Here we have, in a box this big, 3,000 animals that are identical, or 3,000 flies that are identical, that you then bring down and you do your analysis. So there's a lot of statistical power to using these simple models and then understanding something in a more complex system like the human. So I think with that, I will stop and take questions.